Morning, everyone. Let us discuss about Navy-based text classification. In the last session, we have seen one example under Navy-based where we have taken the help of NGS code dataset, right? Latent dataset. So where it is a concept learning task. Here it is a text classification. Classification that too we are performing it on a textual data. So similar to the Navy-based example, here also you are given enough number of training examples, followed by that you are given with the test data also, or the new document is given. So now you have to classify based on the existing training data. We have to classify whether this belongs to T or A, the target label. So our final classification should be either T or A for this particular document. So that is what we have done in the earlier example. Here also we do the same thing. So here, first of all, let us get introduced with some vocabulary. So first thing is examples. So in the given example, a total of 4 documents are given. So all this we will be calling as examples. And every time we will be considering the cardinality also. So if you take the cardinality of examples, how many documents do we have? We have 4 documents. So mod examples are 4. So now if you observe, we have 2 target labels. Let us indicate the target label with letter V. We have 2 target labels, V, comma, A. So when we have computed the probabilities, we indicated the same thing with Vj, right? Vj is T, comma, B. So now all the documents that are there with one specific target label. So we call this as docs J. So they ranges from 1 to n. So like that you can have any number of target labels. So here we have 2 target labels. Let me write it as docs 1. Okay. And the number of documents that you have under this are again 3. Similarly, with target label A. So let us call this as docs 2. And the number of documents that we have here in this example is only 1. Now, other than the target label, whatever documents I have with docs 1, if I concatenate all this, so that I will call text 1. Text 1 is concatenation of document 1, document 2, and document 3. And now, if you observe the number of words that you have in this text 1, n let us take it as n1. So n1 is the number of words that you have. So here actually in this example we have all words only. Actually it need not be a word, it can be a token. That means it can be a number or it can be any special symbol. Okay, so it can be a token. We have to collect all the tokens in this all together in all these documents. How many words do we have? So let us just count it. 1, 1, 2, 3, 4, 5, 6, 7, and 8. So in text, so N1, the number of words that we have in N1 are 8, or the number of tokens, let us take it as. So similarly, text 2. So text 2 contains only one document because the number of documents in docs 2 is only 1. Okay, that is D4. So how many words do we have here? Let us take it as N2. The number of words that we have here are only 3. So just to indicate it belongs to text 1 and text 2, I am giving it as N1 and N2. And let us also catch one more, that is vocabulary. So vocabulary is all distinct tokens from the given documents. Okay, so here you should not forget the word distinct. That means if any word is repeated twice, we will not collect that. So now let us see for the vocabulary first. Okay. So if you observe the vocabulary, Telangana, and let us count also. Okay, so Telangana, so this appeared for the first time. Let us mark it as 1. Then Hyderabad, 2. Again Telangana, it is not distinct. The word is repeated, so I'm not counting it. Again Telangana, not counting. Warangal, the distinct word, so we are collecting. And then Telangana repeated again. Khammam, it is distinct. Then Vizag and Andhra. Here Telangana is repeated, so we will not take. So now if I take the cardinality of vocabulary, so that is if you take a modulus on the vocabulary, how many distinct keywords, how many distinct words or tokens do we have? It is only 6. Okay. So with this information, let us calculate the prior and conditional probability. In the Navy pairs also we have calculated prior probability as well as conditional probability. Here also we do the same, but the way we do is little different compared to the Navy pairs learning task. Okay, so let us see how to calculate the prior probability first. In order to calculate the prior probability, the formula is P of Vj is equals to mod box j divided by mod examples. Cardinality of dogs j divided by cardinality of examples. So let us calculate P of t, which is associated with label T. What is the dogs that we have? It is dogs 1. The cardinality of dogs 1 is 3. So let us take it as 3. And cardinality of examples. Cardinality of examples we already computed, which is 4. So P of T is 3 by 4. Similarly, P of K is then dogs 2 now I should consider. A is associated with dogs 2. So cardinality of dogs 2 is 1 divided by number of examples are 4. Okay. So this is how we compute the prior probability. Let us also see how to compute the conditional probability. The conditional probability we have to calculate for each distinct word in the examples. Let us do that. Let us calculate the conditional probability. So to do this, we will be indicating the conditional probability as P of Wk by Vj, where Vj is the target label, that is T comma A. Wk is each distinct word or in the examples, each distinct word or each distinct token in the examples. So the formula for this is Nk plus 1 divided by N plus mod vocabulary. We already have all these values. Okay. So here this N is nothing but when you are working with the target label T, this is N1, where N indicates the number of words in each text document. Okay, so in text 1, how many words you have, in text 2, how many you have. So that we should consider. Here, if you observe this 1, so that 1 is taken as a Laplace smoothing value. So why we are taking that, I will explain you when we solve the example. Okay, so as of now, let us take it as the Laplace smoothing value where k value is equals to 1. So Laplace smoothing value we are taking with k equals to 1 and here nk. So this NK indicates once again the number of times a particular token is repeated in that particular text. Okay, so if I am considering text 1, in that text 1, total how many times it is repeated. If I am considering text 2, how many times it is repeated. Number of times repeated. Where n indicates the number of words in either in text 1 or text 2. Vocabulary we already calculated. So now let us do the conditional probability for the first word, that is Telangana. So let us write it as P of Telangana given T. Okay. So now if you observe, so when I am considering the target label T, okay, with respect to T, so then which document should I consider? I should consider text 1, which is a combination of doc 1, doc 2 and doc 3, right? So now Telangana, how many times is it repeated? So that's what we should see. So now if you see Telangana, here we have the first occurrence. This is the second occurrence, third occurrence, fourth occurrence, and fifth occurrence. Only associated with target label T, Telangana is repeated for 5 times. So NK value is 5. NK value is 5 plus 1 divided by the number of words that I have in this particular text 1. So that is 8 plus mod vocabulary, which is 6. This we already pre-computed. So the final value of this is 6 by 14. So similarly, let us calculate the conditional probability of Telangana against the target label A. Against A. So now let us see under the target label A. Okay, the doc that we have is text 2. That document is D4. So in D4, how many times it is repeated? Let us see. It has only one occurrence. So let us take it as 1. NK value is 1 plus 1 divided by the number of terms that you have in this document, that is N2 value is 3 plus mod vocabulary is 6, which is 2 by 9. Similarly, we have to compute the conditional probability for all distinct tokens that we have in this document or in the entire examples. So let us do it. I have just tabulated all these values for your quick reference. So this is the algorithm that we are going through. So if you observe the algorithm, we have the training part followed by we have the classification. So in the training part or in the learning part, first of all these values are computed and the data is prepared. And followed by that, when classification is done, once again there we will be using the VNB, using which we will be calculating the Argmax value, and based on that we will be classifying the particular text document. Okay, if there are any students preparing for exams, you should present this algorithm first and then proceed with the example. So the prior probabilities which we have just computed and the conditional probabilities. Okay, so similar to Telangana, I have also computed for Khammam. As a self-learning, you can do this and verify with my answers. Khammam, Warangal, Vizag, Andhra. So for all the distinct words that we have, I have computed the conditional probability with target label P and A as well. So now let us take our new instance and try to compute the VNB value. So this we have done already in the last example. So I'm directly going with. So as we already know, VNB is Argmax. Bj belongs to P comma A, two target labels. P of Vj, that is the prior probability, multiplied with I belongs to positions. P of Ai, which is equals to Wk by Vj. So the new instance that we have taken in this example is Telangana, 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 Vizag and Andhra, right? So now if you, for each, your I is belonging to this position. So initially I belongs to 1, then I belongs to 2, I belongs to 3, 4 and 5. So for all these positions you have to complete, you have to take the conditional probability value and multiply it. Okay, so that is the meaning of this phi of I belongs to positions P of Ai. So now we have taken P of T. Initially, Vj value T we are taking. So it is P of T multiplied with P of Telangana given T. Okay. The first I value. The second I value is Telangana given T. The third I value Telangana given T. The third I value is 4. Sorry, next I value is 4. So conditional probability of Vizag given T. And similarly, the conditional probability of Andhra given T. Okay, so this whole thing is VNB of T value. So now similarly, let us compute VNB of K also. Okay, so this is the value of VNB of K. So the I value, I positions remains the same. The only change if you observe from here to here is the target label is changed. So now the prior probability P of A multiplied with the conditional probability of Telangana given A. So this Telangana given A is repeated for thrice. So your I value is incremented by one at a time. So you have to consider all these three. So you should not take the distinct terms. So you, that one point you should remember. So this is repeated for 3 times. So in the document, this is taken as 3 different tokens. So you should not take it as a single word. So we are taking the conditional probability of Telangana given A for 3 times multiplied by conditional probability of Vizag given A, conditional probability of Andhra given A. So now let us just substitute the values. And after simplifying, so these are the values that we got. Okay, so we already worked out with the R max. So in the R max, whichever value is maximum, only that we will consider. So out of these two, this is the maximum value, right? So VNB of T we calculated and VNB of A also we have computed. So we got maximum value for VNB of A. This is the maximum value. So what will be the classification? So finally, the target value is labeled as C. That means the new instance or the new document, whatever we have taken, that is labeled as T. So that means this new document belongs to Telangana. As per the content that we have and as per the probabilities that we computed and as per the VNB value that we have calculated, the final classification that is done is So the new document was classified as T. Hope you followed the concept. If you have any queries, do post in the chat box. Thank you.